This video is about the lab presentation. I will introduce my team members, which are Nevinesh, Privina, Balkis and Afifah. And then the lab that we choose is lab 3, which is PID controller, tuning of simulated gas mass flow process. Firstly is the introduction of PID controller. PID controller is the proportional integral derivative controller. A PID controller is an instrument used in industrial control applications to regulate temperature, flow, process speed, and other process variables. PID controllers use a control loop feedback mechanism to control process variables and are the most accurate and stable controller. PID control uses closed loop control feedback to keep the actual output from a process as close to the target or set point output as possible. Next is the loop tuning method. The first method is Cohen-Kuhn. Second method is Ziegler and Nichols. And third method is internal model control. Firstly is Cohen-Kuhn. The Cohen-Kuhn tuning rules are suited to a wider variety of processes than the Ziegler-Nichols tuning rules. The Ziegler-Nichols rules work well only on processes where the dead time is less than half the length of the time constant. But Cohen-Kuhn rules aim for a quarter amplitude damping response, although quarter amplitude damping type of tuning provide very fast disturbance rejection. It tends to be very oscillatory and frequently interact with similarly tuned loop. Is the Ziegler-Nichols. Ziegler-Nichols rules are widely used to tune PID controllers for which the plant dynamics are precisely not known. It can also propose rules for determining values of proportional gain Kp, integral time tau d, and derivative time tau d. And Ziegler-Nichols tuning rules can only be applied to a plant exhibiting S-shaped behavior for a unit step unit or exhibiting sustained oscillation for any gain K. In some cases, for a plant having an integrator, the Ziegler-Nichols rules may not be applicable as it won't satisfying. Lastly is the internal model control. IMC especially possesses many advantages over the PID control, particularly in the presence of the significant process dead time. IMC simplify the control system design in a large class of industrial applications for the disturbance response. One of the simple control system design approaches utilize an optimal control theory.